Hi guys, I hope you're really well. I know that I was out of the internet for some time. I'm so sorry I some health problems, but I'm here. So our next topic was about the how to calculate V-welds. So let's start with this. I have this example and we're going to show you part by part how to you can use this information. Okay, remember that this Excel is I'm gonna show you how to calculate, but you should do it by yourself because I think it's the only way to learn it is to practice, 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 practice. Not all day, just maybe an hour per day, 50, I don't know, 30 minutes maybe of practice. Okay, this is the example they say and the center eccentric press works with 50 RPMs and make 50 cuts per minute. The transmission system of the press is compounded by an electric motor, belt, intermediate shaft, and a gear motor. Some of the values or data that we have is our first step is by belt, gears in second step, the gear radio is 4.8, the electric motor we have the power and the RPM, the start torque we have this information with the nominal torque of the machine. You can estimate this. Maybe if you don't have it, you can estimate it. I'm going to show you how. And we have the electric motor shaft diameter of 42 millimeters. And the question is if the press is working 18 hours per day, define what the belt graph and KV are the best option of the system for the system. So first we need to know it's we only need this information and we have to remember these two things. Okay. Something about this, we don't have the efficiency of the electric motor, but remember that we why I put this because you were in this case of the power of the electric motor, we should use the theoretical power. So if you have the efficiency, you should divide the this power and the efficiency. So you have the real power because this is the inlet power, maybe how if you say that. So don't forget it. This is the case because we don't have it. And something this about it's how about radio theory. In this case, it's for gear and belt for the system. But if you don't have it, uh, it could be for gear and maybe not belt, maybe chain, maybe I don't know, different transmission system that you could have. So this is in case you don't know how to calculate the radio of the system. This is an idea. Okay. First, we should start with the information. So we have the RPM of the motor. This is the principal information. We have it about the machine, how it is working, 50 RPM. So now you're gonna see we have the radio of the system also, because we have the first RPM and the last one about the machine how it's working. So we can have this radio of the system. And how we're gonna use for this in the case of gear and belt? Well, we have the radio of the gear, and if you use it, you have the radio of the belt. We were talking about it. That's divided. In this case, the power of the electric motor we have 13.4. Okay, and we should select it. Sorry, this is in Spanish because the last video was in Spanish. Okay. Something that you should is we are gonna show you how to use this off the belt information for select your best option of belt. In this case, for B belt. Okay, so we have the service factors, table 23. So let's search it. You can, as you can see, this is on the internet, so you can just download it. Okay, it's here. We're gonna zoom it. Okay, power. the load factor maybe. I put service factor, but okay, load factor. I'm gonna change it maybe to not confuse. Okay, as you can see, you have this information about the situation that you have it. You have some examples to explain you in what is in your case, and so you have this. You have to match it. As you can see, we have the power of the electric motor. We have an eccentric press, and we are gonna use to this information. So as you can see, like drives is centrifugal power, compression, belt conveyors, or up to, okay, we have these presses. We are here. As you can see, you have different examples, so you should search it. We have in medium drives, okay, we don't have presses here. We don't have it, so we are here. So we are in this line, and now we should select in what part we are of here. As you can see, this say motors of three-phase induction by a nominal starting torque up to, so we are, this is up and this is over. So we know about the principal information that we have here in this case of the example. We are here, but maybe if you don't know it, you can actual uh, you can actual try to put two cases. Okay, but this information you can also have it about the electric motor plate. So that's very information of the brand, maybe I don't know. Okay, and you have the working hours. So we have 18 hours in this for this case. So we are over 16. Sorry, we are over 16. So we should put 1.3. Okay. Oh no, sorry. This is up to the over. Okay, we are here. No, wait. I'm so sorry. I mean, sometimes I kind of confuse it. So we are here. Up to 1.8 times torque, we have 2.2, so it's okay. And we are over 16, so we here. I'm so sorry. I'm just gonna stop. Just sorry. So we are here in this case of 2.2, and we have to select this. Okay, presses 3.2 it's over 1.8, and we working hours it's over 16, so 1.4 it's our value. So we just put here 1.4. This silicon motor power, it is an equation that is here. Something that you should remember that I'm not here invented something new. This already exists. This is already used on all the industry. So I'm just gonna show you how they do it. Okay, I'm not invented anything. So you should just multiply this the power, your inlet power for your load factor. You have this information. So now you should go for the belt profile you should select. So in this case, it's diagram. Here in this case, you have 3 or 4, maybe. Okay, you see, you have different cases of selecting depending on the norm that you should. In case, well, I learned it in with being norms, but if you have more comfortable with others, it's the same. You should just select it your best option. Okay, I'm gonna show you this for high performance because this is classic. So I'm gonna show you something better. As you can see, the design powered. or well, I put the selected motor power right here. We have almost 20. We are here, and the speed of the small pulley is our first speed. Okay, this or the drive in this case. We have the radio, the speed of the belt. This we have 240 volts. So we should just select. We are here. Try to put this on a line right here. Maybe you can see. Try to put this here. At the first speed, you have 1,000. Oh, yeah, 1,700. It's here, almost here. We are here. So we have SBZ. This is just to put it information. This is the RPM of the driving pulley. Remember, you have a radio, and we have here. Remember that the shaft of the diameter of the electric motor. We have this is a recommendation for your calculation. Your start calculation twice the diameter. I put this 42. It's information. And for here, this is the that you have, but you should select what is the normal on the market. So we're here. This is something that I'm going to show you in the table 5. Okay, now 15. So we're here. These are the nominal diameters that we have for different drive pulleys. In this case, that's the reason why we select the belt profile. For this, we have SPZ. So we are here, and we have 84. There is and it says 84. We have 85. So you should put 85. Just always over your value. Never less. Never up this. Just over this. So as you can see, if you continue using the radio of the ball, you have the driving pulley, but we have 618. So now we should select what is the next. As you can see, we don't have it. We have 630. So just put it on this. So now we should put the drive center distance. You should have this recommendation if you just multiply. I'm just gonna put this for this part. As you can see, now you have the information of 85. The real is okay, and twice the same. So you have it. So I'm gonna put, I don't know, 1,000 because it's in the middle. This is not just a range. And put this. Now this is an equation to calculate the belt length. Is this? You have this information because you have your drive center distance. Theoretically, yes, it's a preliminary calculation. Now you should calculate the real belt length, and this is also on the market. In this case, we have table 24, and as you can see, you should know your profile. That's the reason why you should always know your profile. That depends on where you're gonna go. And we have 3,196. The recent we have, I think it is, I know it's 96. We should select the next one. In this case, is 3,350. because this is in the real market. Now we should calculate the real drive center distance. It's about this C. How you're gonna I put it by hand. You should calculate on a different paper, or maybe you can have a um, an Excel by part. You know how to do this by your first class of mathematics. So I'm just gonna put it because I already did it. So this is 1090. If you don't remember how to do this, this is a question of, how can I say, Ruth? Searching the Ruth, maybe? Okay, this is in Spanish, you know, something like this. Okay, this is in Spanish, but I don't know how to say it in English. And next, you can also calculate your belt speed and your belt flats. How you're gonna do it? When you have this equation, you should multiply your drive pulley diameter with your RPM and divide it with this number. So just put it to calculate the speed, and in case of flats, it's just this 2000 per the speed divided by your real bed length. How is the nominal power now? We have done all of this. We have the table 32. So we have to look with the RPM on the electric motor and your nominal drive diameter. So it's here. As you can see, we have 1745 RPM. It's not here, it's in this two, and we are here. So we should interpolate also. Just put this, that's the reason why I have this information here. And the next number is 2000. Okay. And the values of this 85 is 2.56. Okay. Okay, this is in this case the nominal power that we should put. Let's put it 2.956. Okay. I put power by supplement. This is the additional power depending on the radio. We have a radio of above 1.57 radio. It's here about the first information that we have. Okay, 7.27. So we're over this. So you should put 0.23 and 0.46. 0.23, 0.26. If you didn't remember how to interpolate, you just can see it, or you can search it on the internet. Interpolation. As you can see, you have it. You can just search it. And I put 0.2363. Okay, so this is the value that we should put. As you can see, this power plus supplement. So you should just put this plus what I have 0.236. I know that I could put another row with this, but well, it's already done. This super factor, it's a calculation. This I don't have a number. but I put this input factor because it's the information that you know to select the next one, the next part. As you can see, the information table 22, and as you can see, you're gonna see this equation here. You know, this is the equation. So same with our values. With this, we're 0.505, 0.505. It's between this. We have these two angle and the different contact angle factor. How we are gonna select this? With the same 0.5, you should interpolate. As you can see, you have a lot of info, a lot of parts when you should interpolate 0.5. But here, it's the same. So you don't have to do it. It's the same in the case of the angle factor. It's the same in the case of the drive pulling angle. It's different, so you should do it here. Uh, so this, just put it. And this is the bell length factor. It's another factor here. C3. And we have a belt with this length, and the factor is 1.13. So just put it 1. This number of belts theoretically, you can see, is this. Okay, this is the equation of how to calculate number of belts. The first is the power of the electric motor multiplied with no, I'm sorry, the power of the electric motor that we have multiplied with the load factor, and this you should divide it with the multiply of this power plus the supplement or additional power that we select. That it's also multiplied with the contact angle factor and the belt length factor. This is the number of belts. So maybe, but how is the real belt that we have 5? You should always go by over this number if you have these cases. You should always go with over this number. In this is the information of belts that it's updated, but this don't have how you can combine your belts in the market. This just have some information of for some belts. I'm gonna show you. Not here. Here maybe. I know. It's not here. But in the old version, you have it. That's the reason why you have this old version. It's in Spanish, but you just can see. This is the number of groups, and this is how you can combine your belts. In we have a case, we don't have, no, we just have, we don't have 5.31. We have 5, but remember that you should always go over of this number. So our case, it's 4 seats. So how we should combine it is 3 and 3. If you have number of pulleys, maybe 40, this is the combination of your belts that you should buy. This is how you're gonna buy your belts. A belt of 5 groups, pulley 8, 8. So you have the 40. In our case, we have 3 and 3. Just try to be careful with the information that we have it. So As you can see, this is our leg factor, and just that. I here I have a mistake. Oh yes, remember our belt. Okay, 6 is our number. So for this question, the answer should be we have how can I write it? Want, or maybe it is just this, want drive fully of um what was the number? That is 85. One drive pulley of 85 millimeters and six groups for a V belt with a SPZ profile. Okay. Second of these uh, is the same, but we have one driving pulley of 630. Okay, 630 millimeters and six groove of V belt profile. The next one we have one um one multiple belt Craftsman AB three three SPZ of 300 3,350 millimeters of length. Okay, now you know that in case of seats is 3 and 3, it's just not one, it's two about quantity. So this is the selection of your uh, this is your answer for this case. So well, I hope you really fine. Sorry if I'm kind of maybe my English is not the best, but I just wanna try to show you how to do it or to share information. But if you have any question, please just let me ask, and I'm gonna help you. Okay? Okay. Have a nice day, and I hope you really well.